Hello students, I'm Miss Slate, and today we're going to talk about how to write the names and formulas for ionic compounds. So first off, ionic compounds are ones that are composed of positively and negatively charged atoms, called ions, that combine to form neutral compound. Metals tend to form positive ions, we call those cations, and nonmetals tend to form negative ions, which we call anions. The chemical formula for an ionic compound is called a formula unit. And that's because a formula unit represents the lowest ratio of ions in an ionic solid. So typically, when you have like an ionic crystal, there's all number of positive and negative ions just surrounding each other. The formula unit just tells you what the lowest ratio of all those ones are. So is the lowest ratio 1 to 1? Is it 2 to 1? Etc. Now, something that's going to be handy right now is for you guys to pull out your periodic table because we're going to be labeling some things on it again that's going to make our lives easier. As a reminder, the columns on the periodic table are called groups, and what group an element is a part of can also tell us what ion it will form. So, like we said before, metals tend to form positive ions. The metals in group 1A all form positive 1 ions. Metals in group 2A form positive 2 ions, and metals in group 13 or 3A form positive 3 ions. So basically these ones right here on the periodic table we can label. The ones in the middle are a little tricky, and we're going to talk about them in a second. All those metals that were in the middle form multiple ions, meaning, they can form more than one charge. For example, iron. Iron can be a positive 2 ion, or it can be a positive 3 ion. So for those particular metals, we need to include a Roman numeral after their name that tells us what the charge is. So for example, if you have an iron positive 2 ion, we call that iron Roman numeral 2. And so all of those metals in the middle, from scandium all the way to zinc in that section, are going to need Roman numerals, with the exception of 3. So cadmium, zinc, and silver don't typically have Roman numerals after their name because they are the only 3 metals in that section that only form 1 ion. Cadmium and zinc only form positive 2 ions, and silver only ever forms a positive 1. So we're actually going to make a note of that on our periodic table as well. So I kind of put like a little star next to zinc, cadmium, and silver. They're all kind of in the same area. And then I made a note at the bottom of my table that says, don't need Roman numerals. Zinc +2, cadmium +2, zinc positive. So I would make sure you add that to your table as well. Because again, all of these notes are going to be here to just help us with this. Now let's talk about the nonmetals. Nonmetals in group 17 or 7A form negative 1 ions. Nonmetals in group 16 or 6A form negative 2 ions. And nonmetals in group 15 or 5A form negative 3 ions. The one exception to all this is hydrogen. Hydrogen's kind of a goofy little atom because it can form either a positive 1 or a negative 1 ion. And you're going to be able to tell which one it's forming based on where in the chemical equation hydrogen is. Because when you're writing a name or you're writing the formula, we always put the positive ion first, and then we put the negative ion second. So if hydrogen is at the beginning of a compound, it's a +1. But if hydrogen's at the end of the compound, it'll be a -1. So here's kind of the visuals for those particular groups on your periodic table. Again, make sure you jot down the charges formed by elements in these groups. Now, group 14 or 4A tends not to form ions, but they could technically be a +4 or a -4. It kind of depends. So carbon, silicon, and germanium don't often form ions. Tin does. Tin is usually a tin 4, but it can also be, I believe, a tin 3. And then all the elements in the last group, group 18 or 8A, Those are all noble gases. Remember, they have full valence electron shells, so they don't form ions at all. And therefore, they tend just not to be a part of chemical bonds. So here's our list of Roman numerals. Jot down the Roman numerals in your notes so that you remember which ones are which. You're really only going to need to know or use 1 through 6 because we don't typically deal with any ion charges that are higher than 6. Most of the time it's only going to be 1 through 4. But jot those down, especially if you're not super familiar with what all the Roman numerals are. That being said, if you ever forget what Roman numeral 3 is or something, just ask me and I'll help you out with that. So now let's talk about the process of writing names for ionic compounds. So first off, you are going to write the name of the positive ion. This is typically the metal. And you're going to include a Roman numeral if necessary. Remembering, of course, that metals in group 1, 2, or 13, also known as 3A, so metals in group 1, 2, or 13 don't need a Roman numeral, but everything else is going to need a Roman numeral to represent its charge. So if it's not a part of those 3, it'll need a Roman numeral. Once you have the positive ion's name written, you're going to write the negative ion name and change the ending to IDE. So that's going to be a common theme, is we're going to be changing the ending to "ide." So let's do some examples with this. So we've got MgBr. Well, once again, you are you're going to need your periodic table because you're going to need to look up what the symbols of all these are. If you look for Mg, you'll find that it's the element magnesium. So I'm just going to write magnesium. Magnesium is a part of group 2 on the periodic table, which means no Roman numerals necessary. So then we just look up Br, and you'll find that Br is the element bromine. So once again, we need to make sure we change the ending to IDE. So we're going to make it bromide. And there we go. We have the name written for magnesium bromide. Let's do one more. Let's do an example where we have to write the name for FeS. So Fe, you'll find on the periodic table, is iron. Iron is not a part of group 1, 2, or 13, so it is going to need Roman numerals. So I'm going to kind of just leave myself a little space so that I remember to come back and do my Roman numerals at the end. Next up, we have the element S, which is sulfur. Again, we have to change the ending to IDE, so I'm going to make it sulfide. All right, so now we have to figure out what our Roman numerals are for iron. Remember, iron, the Roman numerals for these metals are based off of what charge the ion has. Well, just by looking at the neutral compound, we don't necessarily know what the charge is. So we kind of have to work backwards here. So we know that there is one iron ion in this compound because it's just Fe with no subscript. We also know that there is one sulfide ion because, again, there's no subscript. So we don't know what the charge on iron is, but sulfide is a part of group 16 or 6A. So we know that it's going to be a -2. So here's where we're able to kind of figure this out. So we know that when these two ions come together, they need to form a neutral compound, meaning that their charges must add up to 0. So if sulfur is a -2, we have to ask ourselves, what does iron need to be to make those charges add up to 0? Well, in this case, iron must be a positive 2 if they're going to add up to 0. Negative 2 plus positive 2. So in my name, it needs to say iron 2 sulfide with our Roman numerals. And so iron 2 sulfide would be the correct name for FeS. Now let's talk about writing formulas. Writing names tends to not be too bad. It's just remembering how to figure out the Roman numerals. Writing formulas can take a little bit more thinking because we always have to work with those charges. So the first thing we have to do when we're writing the formula for an ionic compound is to determine the symbol and charge of each ion, and then we need to combine the charges in the lowest ratio to form a neutral compound. Drawing little diagrams or like keeping track of the charges in the margin of your paper is going to be really helpful with this. And once you've figured out what that ratio is going to be, you're going to write the formula using the element symbols and subscripts to represent the ratio of the ions. But you're not going to have any charges in the final formula because the ions are always going to come together to form a neutral compound. And this will make more sense when we work through some examples. So our first example is iron 2 bromide. Well, it's really convenient that it's iron 2 because we automatically know what the charge on iron is. If it's iron 2, that means it's a positive 2 ion. Because remember, the first one's always positive. And then we have bromide, which if you look on the periodic table, bromide is a negative 1 charge. Now, these are going to come together to form a neutral compound, meaning our charges need to add up to 0. Right now, we have positive 2 plus negative 1. Well, that does not add up to 0. To make it add up to 0, we need to add another negative charge. If I add another negative 1 ion, well, now we have negative 1 plus negative 1, that's negative 2, plus our positive 2 gives us 0. Now we have the correct formula. So now we can go and write it with our symbols. So we start with an Fe for iron. We have 1 positive 2 iron atom. So we don't need to add any subscripts to iron because there's only 1. Next up we have bromide, which has the chemical symbol Br. And we have 1, 2 bromide ions. So I'm going to put a little subscript 2 after the symbol for bromide. So the correct chemical formula for iron 2 bromide is FeBr2. Let's do another example. This time we have lithium fluoride. Well, fluoride, that has the symbol of a capital F, and it's a part of group 17, or 7A, which means it's going to have a negative 1 charge. Lithium, on the other hand, has the chemical symbol Li, and it's a part of group 1A, so it's going to have a positive 1 charge. Well, if we've got a positive 1 and a negative 1 ion, well, positive 1 plus negative 1 does add up to 0. So I don't need to add anything else in this case. We can just write the formula. Li for lithium, we have just 1 lithium ion, so no subscript needed. Then a capital F for fluoride, which again, I have 1 fluoride ion, and so I don't need any subscripts. So LiF is the correct chemical formula excuse me, for lithium fluoride. And we'll do some more practice and examples with this in class. So So if you don't totally understand everything right now, that's okay. But this will give you a start for when we start doing some work with this in class.